revolution about the x-axis. So we are going to do some crazy volumes right now. This is not on your exam. They moved this to HL only. It used to be part of the SL. Moved to the HL. It's just, unfortunately, way too cool not to show you. So, here is a volume formula you already know. Wow. This is a cylinder. The formula for the volume of a cylinder is pi r squared times h. And what I like to use as a visual of this, pi r squared is an area of a circle. And if you took one circle, cut it out of paper, it would fit nicely right on the bottom. Then you take another circle, cut it out of paper, and put it on top, and slowly keep stacking circles of paper. It would eventually fill this whole can, and it would be solid, full of paper. And so what a volume formula is doing here is it's taking the area of the base, basically that circle, and adding them all up with the height, giving a volume. So what we do with integration is we say, well, if an integral finds an area under a curve, and if we make that area under the curve really, really, really small, here at A, it would basically be a tiny thin rectangle, almost the radius. And if we took that radius and rotated it 360 degrees about the x-axis, we would get a circle. Now, our curve changes, so the amount of circles change as we go along with it. But if we find the integral under here, take all of those and make them circles and add them all up, we can get the volume of very crazy shapes. In fact, this second picture, we now know how to do the area between two curves. If I would take this, rotate it 360 degrees, can you see a picture? It like makes a bell. And you could figure out the volume of that bell with a simple integration. So here's the idea. The idea is that our integral finds us the radius, and all we do is pi radius squared, pi r squared, that gives us a circle. And if we find the definite integral as we go, we're going to add up all of those circles, which will give us the volume. And it used to be in our formula booklet like this, but you don't have to worry about it because it's part of the HL now. But it's just so cool to figure out and solve. So we'll go through this and have some fun with this just to see what it would look like. I want to just draw them out. Yeah, I'm not happy with that picture. I'm going to redraw it. I'm going to redraw it. Y equals x cubed looks like this. It goes through the point 1, 1 and 2, 8. The way that you draw these is you imagine rotating this section around, which would put this down to here and down to here. And then from this point to this point, for 3 dimensions, we draw an oval. And from this point to this point, we draw an oval. And then what I find really helps you see the final picture is if you take out 2 different colors. Crayon is wonderful in this option. Color one of the circles in. Looks like a watermelon graph. And when you color it that way, can you see the three-dimensional shape a little bit better? We have to sort of imagine the red part is a circle, but it's on its edge, so it looks like an oval this way. And there was a circle here on the end, but you can't see the red part. And if you imagine cutting a watermelon that was in this shape, there are people that do that. They make watermelons in different shapes. Have you heard of that? Really expensive watermelons, I think in Japan, are cubes. And they can actually stack them. So you can, and they grow the watermelons in a box so that they form into a cube. And then you buy your watermelon cube. Very cool. Okay, I thought of something. I was like, next, babies. So bad, right? Little square babies. What are you doing? Okay, all right. So once we have the picture drawn, now our integral will go from 1 to 2. The equation is x cubed. That x cubed gets squared, because that's your radius squared, and you can either have pi inside or pull pi out. And this is an easy integral for us to do because it's x to the 6th. That'll just be x to the 7 over 7. And we just found the volume of that watermelon. In fact, actual watermelon is pretty symmetrical about itself. If you could find the equation of the top curve, then you could find the volume of the watermelon, or the volume of a football. It's even got watermelon seeds in it. This is such a good diagram. It's almost summertime. 12 classes left till your exam. Whew. Okay. Next example. Okay, first of all, I'm going to redraw it because that's okay, but it's just too much fun to draw. So we're going to start. You start by graphing square root of x minus 1, which is your square root graph. Move 1 to the right. Which would look like that. You can then replicate it underneath, because it's going to get rotated around the x-axis. From 1 to 5, so at 5, I imagine that is the diameter of the following circle. And color coding this again, choose one color to color in the circle, and another color. Yes. This time, we are making a ham roast. There it is. Oh, you guys are going to be hungry after class today? There is a ham roast. And so to find the area of that ham. And this this is where things turn out really nicely, because the radius was a square root, it gets squared, which makes it a really nice equation. We just have the integral from 1 to 5 of x minus 1 That's an easy integral because it'll be x squared over 2 minus x. I'm sure you don't have to write down the numbers. It's equal to 8 pi. Super cool. And not hard. Like now, we started with just finding areas under curves, which was amazing. And now we can find crazy volumes with such a simple idea. Oh, I like this one. Are we good? Okay. And I'm going to, yeah, not a good enough drawing. Here we go. So your cos graph from 0 to pi over 4, your cos graph, I'm going to put pi over 2 here and pi over 4 here. Cos graph would look like this. That would be part of our cos graph from 0 to pi over 2. And then, of course, it would keep going like that. Our sine graph, which I will do in green, would be at a maximum at pi over 2. And it would keep on going like that. So now we are going to take the sine graph and flip it over. Our cos graph and flip it over. And what we're going to imagine, okay, and what we're going to see when this gets rotated, I'm going to draw from this point to this point a circle, and this whole thing gets rotated around. Can you imagine, I'm going to color something in here to help you imagine. This is going to make, okay, imagine you want to get you have a pet, a little cat or a little dog, and you're planning to make them a mathematical water dish out of titanium. Okay? So what you're deciding on doing was taking the sine curve and the cos curve and where they intersect and rotating them. Can you see that this would be solid here? It would be a hole in the inside with a tiny little dot hole at the bottom. You might have to just dab that so that it wouldn't leak or anything. And the inside is going to be the shape cut out by the sine curve, and the outside is going to be what's left from your cos curve. And you're wondering, how much titanium do I have to buy to build this? From 0 to pi over 4, what it's going to be is it's going to be the volume of the one minus the volume of the other one. And because integrals can be put together, you could factor out the pi, and it will just go from 0 to pi over 4 of cos squared x minus sine squared x. And currently, each of these on their own, you actually cannot integrate. If you tried to integrate cos squared x on its own, it doesn't integrate well because it's a chain rule, and we don't have good ways of undoing a chain rule unless we can use substitution. But if we notice that cos squared minus sine squared is an identity, we can change that to cos 2x. And cos 2x is an integral that we can do. Is titanium easy to buy these days? Is this still pretty expensive? I don't know. I have not bought titanium for the longest time. Not sure where I would go to buy a block of titanium. Okay. $2014 would be worth $6,100. So, but that's a while ago. Okay. But then another place just says $16, so maybe it was on sale. I'm not sure. Current price says 35 cents a pound. I don't know. Depends on which website. Titanium might be cheap someplace. I'm not sure. Anyways, this integral, oh, I just had my eraser button on. Here, let's go undo. There it is. That integral is just sine 2x over 2 from 0 to pi over 4. And then it becomes a pi plate question where you plug things into there and figure out using your pi plate. And all you would need is pi over 2, whatever units we're using, cubed. Maybe you want to make it out of gold. Maybe gold is easier to find than titanium. You really like your pet. Okay. So, with that, pause the video. That was our last yes.